Good morning students. Today we discuss about the concept as atomic spectrum here. Generally, as you know very well, what do you mean by spectrum? The definition, as you know very well, the spectrum can be defined as the orderly arrangement of all the wavelengths, that arrangement according to the decreasing order of wavelengths or increasing order of wavelengths, whatever it is. But orderly arrangement of wavelength of all the radiations, we are going to call it as usually spectrum, or you can call it as a spectrum. And here there is a word that is called as atomic spectrum is there. What is atomic spectrum? That is the spectrum produced by, or the spectrum produced due to the transition of electrons taking place in an atom. Let us consider here, before going to the definition of atomic spectrum, what is happening here? Let us consider, this is the atom, this is the first energy state, and this is the second energy state, this is the third energy state, this is the fourth energy state, and so on up to this is infinity. Here number of energy states are there. Here n is equal to 1, this is first energy state, n is equal to 2, this is second energy state, n is equal to, this is third one, n is equal to 4, this is next one, so on up to infinity. Orbits are there. Here let us consider, as you know very well, when the electron is jumping from lower energy state to higher energy state, and whenever the electron is jumping from higher energy state to lower energy state. Let us consider, here the electron is present in the first orbit. In order to take the electron from the ground state to higher state, the electron has to receive some amount of energy. It has to be absorbed some amount of energy from the external sources. Let us consider here, the electron is present in the ground state. In order to jump the electron from first orbit to second orbit, it has to absorb some amount of energy, or else the electron is jumping from lower orbit to next higher energy state, it has to absorb some amount of energy, or the electron is jumping from lower energy state to still higher energy state, it has to absorb the more energy. And here the generally we are going to tell, in order to jump the electron from lower orbit to higher orbit, it has to absorb some amount of energy. Vice versa, whenever the electron is present in higher energy state, this electron, whenever it is jumping from higher energy state to lower energy state, whatever it is the lower energy state, either it is jumping from higher to next level, or higher to this second orbit, or higher to this first orbit, or higher to this third orbit, whatever it is, whenever the electron is jumping from higher orbit to lower orbit, it is emitting the radiation, or it is emitting the energy. It is emitting the energy in the form of electromagnetic radiation, in the form of radiation. Whenever the electron is jumping from higher orbit to lower orbit, it is releasing some amount of energy, that energy in the form of electromagnetic radiation, or else vice versa, whenever the electron is jumping from lower level to higher level, it has to be received, it has to be absorbed some amount of energy from the external source. Let us consider here, I am talking about here atomic spectrum. Whenever the electron is jumping from this, for example, whenever the electron is jumping from fourth orbit to first orbit, whenever the electron is jumping from this fourth orbit to first orbit, it is releasing some amount of energy. And if you take the spectrum of this radiation, you are getting one line here. This line is indicating this is the wavelength of this radiation. Or whenever the electron is jumping from this fourth orbit to second orbit, it is releasing the energy in the form of radiation. The wavelength of this radiation is here. Next, whenever the electron is jumping from this higher energy state to, that is next third orbit, again it is releases some amount of energy in the form of electromagnetic radiation. The wavelength of this radiation I am taking here. Like that, whenever the electron is taking taking the transition from higher energy state to lower energy state, it is releasing the number of wavelengths, means it is releasing number of radiations, and those wavelengths we are taking on the screen. That's why this spectrum we are going to call it as atomic spectrum. Here, what is the meaning of atomic? When this spectrum is produced due to the transition of electrons. Where is the place that the transition of the electron is taking place? That is, where is the place that the transition of the electron taking place within the atom? Within the atom, the transition is taking place in between the different energy states. That's why the energy is released, and the spectrum produced due to the transition of the electrons in an atom. That's why the resulting spectrum is called as atomic spectrum. Here, the atomic spectrum can be defined as it is the regular arrangement of, it is the orderly arrangement of, it is orderly arrangement of, arrangement of, arrangement of, arrangement of wavelengths of, wavelengths of, wavelengths of electromagnetic radiations, electromagnetic radiations, electromagnetic radiations due to radiations due to transition of electron, due to transition of, transition means whether it is jumping from higher energy state to lower energy state, or it is jumping from lower energy state to higher energy state. Whatever it is jumping from higher to lower or lower to higher, whatever it is a transition. Due to transition of electrons, due to transition of electrons, electrons between energy states or between energy levels within an atom. Within an atom means in the atom. Within an atom. This resulting spectrum is called as, this resulting spectrum, this resulting spectrum is called as atomic spectrum. Is called as atomic spectrum. Is called as atomic spectrum. Actually, there are two types. One is emission spectrum. One is emission spectrum. Second one is emission spectrum. Second one is absorption spectrum. Second one is absorption spectrum. Absorption spectrum. First, we will see about what is emission spectrum. Let us consider here what do you mean by emission spectrum here. Here, in order to study the emission spectrum, let us consider again this diagram here. Whenever the electron is jumping from higher energy state to lower energy state, for example, I am taking the consideration electron is jumping from this fourth, this is a higher orbit to lower orbit, it releases the energy, and here I am getting the wavelength on the screen. And whenever electron is jumping from higher to next lower orbit, again it releases the energy. I am taking the wavelength of that one. Whenever the electron is jumping from higher to again next lower orbit, it releases the energy in the form of radiation, and the wavelength of this radiation I am taking here. And this resulting spectrum is produced due to the emission of energy whenever the electron is jumping from higher to lower. When the electron emit the energy, or when the electron emit the wavelengths, or when the electron emits the electromagnetic radiation, whenever the electron is taking the transition from higher energy state to lower energy state, it is emitting some wavelengths, and those wavelengths it produces, or those wavelengths I am taking on the screen with orderly arrangement. And this resulting spectrum I am going to call it as emission spectrum. What is the meaning of emission? Because electron emit the different wavelengths whenever it is taking place, or whenever it is jumping from higher energy state it emits the radiation and its wavelengths are here, and this spectrum is called as emission spectrum. When the emission spectrum produces, just you can consider whenever, or let us consider this emission spectrum can be produced. Let us consider it can be produced by passing electric current through the gases at a low pressure. Gases means the gas consists of atoms. Getting? Here let us consider, here gas is there. These are all the atoms. When you supply the current, in here infinity number of atoms are there. I am considering only one atom for the convenience. Here these are the gas molecules, nothing but they are containing lot of atoms. I consider only one gas molecule. In that many number of atoms are there. I consider only one atom. Whenever the current is passing through these gases at low pressure, this energy, this electrons present in the higher energy states, they are jumping from higher energy state to lower energy state. Whenever these electrons are jumping from higher energy state to lower energy state, immediately there is an emission of this wavelengths, immediately there is an emission of this radiation, and wavelength of this radiation I am taking on the screen. Or whenever another electron is jumping from higher energy state to lower energy state, it is also emitting the radiation. Or another electron, it is jumping from higher energy state to lower energy state, it is emitting the radiation. All these wavelengths I am taking on the screen, and this resulting spectrum is called as emission spectrum. And whenever it can be produced by passing electric current, whenever if you pass the current through the gases, there are infinity number of atoms are there. Inside the atoms there are electrons are there. Whenever the current is passing through the gases, the atoms present in the atoms belongs to the gaseous molecules, they receive the energy, or this electrons becomes unstable by passing the current. That's why whenever the electrons they become unstable, they are taking the transition from higher to lower energy. Whenever they are taking transition from higher to lower energy, they are emitting the different wavelengths, and those different wavelengths I am taking on the screen. That spectrum is called as emission spectrum. And next one, absorption spectrum. And this spectrum also, this spectrum can be, what is absorption spectrum? This spectrum can be produced when electromagnetic radiation passing through the substance or gas. Substance is nothing but that is metal, or some metal or material having infinity number of atoms. Substance or gases, then it can be produced. Which spectrum? That is absorption spectrum. Here what is happening? Let us consider it is an atom. I am passing some electromagnetic radiation through the atom here. Means you can passing through the substance, means substance having infinity number of atoms. I considered one atom here. Whenever you are passing the electromagnetic radiation through the substance, here the electrons present in the ground state, they absorb some amount of energy from the radiation and jumping from lower energy state to higher energy state. And whenever this electron, in order to jump from lower energy state to higher energy state, this electron absorbs some amount of energy from this electromagnetic radiation. Means after that, if you take the wavelength of this radiation, you are getting on the screen as a dark line. Why you are getting on the screen as a dark line? because whenever this electromagnetic radiation passes through the substance, some part of energy or some part of wavelength transferred to the electron of the metal. Whenever this electron is received, absorbed some amount of energy from this radiation, after if you take the wavelength of this radiation on the screen, you are getting the dark line on the screen. What is the indication of dark line? Because this electromagnetic radiation lost some amount of energy. Why it is lost? Where it has gone? Because that lost energy is transferred to the electron of the metal. By taking that energy, that electron what it is doing? By absorbing some amount of energy from this radiation, this electron is jumping from lower orbit to higher orbit. Means in order to take the jumping from lower to higher, this electron is absorbing some amount of energy from the radiation. That's why this radiation lost a part of its energy. If you take the wavelength of this radiation, you are getting the dark line. Instead of getting a color line, you are getting a dark line. It indicates this radiation loses or lost some amount of energy or wavelength. It's lost its energy or it's lost its that is wavelength. Again, another electron for this electron is jumping from this lower energy level to this higher energy level, and this electron is also in order to take the transition from this level to this level, it is also receiving some amount of energy from this radiation. That's why this radiation that is transports its part of energy, its part of wavelength to this electron. That's why if you take this radiation on the screen, you are getting some dark line here. Means this resulting spectrum is called as absorption spectrum. Why we are calling it as absorption spectrum? Because the electron absorbing the part of its energy. Why it is absorbing? Because it has to take the transition from lower energy state to higher energy state. Then from where it is absorbing? From the electromagnetic radiation, it is absorbing the radiation. After that, if you take the spectrum of this radiation, you are getting the dark lines on the screen. That's why this resulting spectrum we are calling it as absorption spectrum. Getting electron jumping from higher to lower, it emits the wavelengths. Resulting spectrum is called as emission spectrum. Whenever the electromagnetic radiation passing through the gases or substance, these electrons are absorbing the wavelengths in order to take the transition from lower to higher. That's why it is giving some dark lines on the screen. The resulting spectrum is called as absorption spectrum. Electron higher to lower jumping, electron emit the wavelengths. Spectrum is called as emission spectrum. Here electron lower to higher jumping, and it absorbs the radiation, absorbs the wavelength of this one. That's why resulting spectrum is called as absorption spectra. Some points are there regarding emission spectrum and absorption spectrum. Just you can see here. What are those points? One is in emission spectra. That is in emission spectra. What is the first point? In emission spectra. In emission spectra. The transition of the electrons jumping from higher energy state to lower energy states. Lower energy states. And this is the first one. In emission spectra, you need to remember higher to lower, electron is jumping. Whenever it is jumping, what is happening? It releases energy. In emission spectrum, electrons colored lines. Colored lines indicating the intensity of this spectral lines is more. Means you are observing clearly the colored lines on the spectrum. It indicates the intensity of these lines is, or this radiation is more. Higher the wavelength, higher the intensity, and there is a more gap, or there is a clear observation of these lines. That's why in emission spectrum, we are observing colored lines. We are observing colored lines. And some points above absorption spectrum. In absorption spectra, spectra is nothing but spectrum. The electrons are jumping from lower energy state to higher energy state. And next, what is the point? Same. In absorption spectra, electrons receive the energy or emits the energy or absorbs the energy. Electrons absorbing energy. And what is third point? In absorption spectrum, we are observing dark lines, or we can call dark gaps. This is called as some points above which spectra. This is regarding absorption spectra. Here, electron is jumping from higher to lower, or higher to this state, or higher to this state. Means generally higher to lower, there is a transition of the electron. During a higher to lower transition, emits different wavelengths. If you taking on the screen, the resulting spectrum is called as emission spectrum. And this emission spectrum, you are clearly observing the colored lines. And here in absorption spectrum, here the electron is jumping from lower state to higher state, first to second, or first to third, or first to fourth, or first to sixth, whatever it is. This is the jumping of electron from lower energy state to higher energy state. And in this absorption spectrum, this radiation is passing through the substance. Whenever this radiation is passing through the substance, suddenly the electrons of the atom absorbs the energy from this radiation. Then after that, if you see the spectrum of this radiation, then we are getting some dark lines. Then how much energy absorbed by this electron in order to take the jump from here to here? ಇದು ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಹೋಗಬೇಕಂದ್ರೆ ಇದರಿಂದ ಎನರ್ಜಿ ತಗೊಂಡಿರ್ತದ, ಆಮೇಲೆ ಎಷ್ಟು ಎನರ್ಜಿನ ಅಬ್ಸಾರ್ಬ್ ಮಾಡ್ಕೊಂಡದ ಅದನ್ನ ನೀವು ಸ್ಕ್ರೀನ್ ಮೇಲೆ ತಗೋರಿ. ಒಂದು ಸ್ಪೆಕ್ಟ್ರಲ್ ಲೈನ್ ಸಿಗ್ತದ. ಫಸ್ಟ್ ಆರ್ಬಿಟ್ ದಿಂದ ನೆಕ್ಸ್ಟ್ ಹೈಯರ್ ಆರ್ಬಿಟ್ ಗೆ ಎಲೆಕ್ಟ್ರಾನ್ ಜಂಪ್ ಆಗಬೇಕಾದ್ರೆ ಇನ್ನೂ ಎನರ್ಜಿನ ಅಬ್ಸಾರ್ಬ್ ಮಾಡ್ಕೊಂಡಿರ್ತದ. ಯು ಆರ್ ಗೆಟಿಂಗ್ ಅನದರ್ ಲೈನ್. ಫಸ್ಟ್ ಆರ್ಬಿಟ್ ದಿಂದ ನೆಕ್ಸ್ಟ್ ಹೈಯರ್ ಆರ್ಬಿಟ್ ಗೆ ಜಂಪ್ ಆಗಬೇಕಾದ್ರೆ ಇನ್ನೂ ಜಾಸ್ತಿ ಎನರ್ಜಿನ ಅಬ್ಸಾರ್ಬ್ ಮಾಡ್ಕೊಂಡಿರ್ತದ. You are again getting the spectral line here. This resulting spectrum is called as absorption spectra. In this spectrum, within an atom, number of electrons, they are absorbing the energy from the electromagnetic radiation in order to take the transition from lower energy state to higher energy states. That's why if you study the spectrum of this one, you are getting the dark lines. The dark line is getting this radiation lost some energy. Why? Because that energy is given to these radiation spark in order to take the jumping from lower to higher. That's why these are the key points. Here, dark lines indicating weaker is the intensity. Here, color line indicating the intensity is more. And this is regarding above and the atomic spectra. Getting the atomic spectra, it is the spectrum produced due to the transition of electrons taking place within an atom. That's why the resulting spectrum is called as an atomic spectrum. There are two types. One is emission spectra, another is absorption spectra. Just you can remember the definition of atomic spectra. That is enough for your examination. And these are just for what is the process actually, what is the key points happening in emission spectra as well as absorption spectra. And just you can remember the statement of that is atomic spectra. And thank you.